among pieces of data. And we'll see in a moment what we mean by that. In fact, the language we'll talk about ultimately today, SQL, or SQL for short, really stands for Structured Query Language, which is a programming language specifically designed for databases. So once we've got a lot of data in a database, SQL makes it easier to get it back out. And in fact, among our goals now for the coming time together is going to be to see, can we take that 14-line program in Python and whittle it down maybe to 1 line of code in a different language, namely SQL here. So what does SQL allow us to do? Even though it's a new programming language, we're only going to spend today on it really, as well as a problem set, though we'll use it again later in the course too to solve bigger and better problems as well. But it really only supports 4 key pieces of functionality that are sort of crudely referred to in the industry as CRUD. CRUD is a helpful mnemonic for keeping track of what you can do with SQL. And in particular, the C stands for create. You can create data in a database. The R stands for read. You can read or access data from the database. U for update, which means you can update or change data in the database. And D for delete. You can, of course, delete data from the database. So even though we're about to see a new programming language, at the end of the day, it really only does these 4 things. Now, technically, and a little confusingly, it literally does 3 of those 4 things using the exact same terminology: create, update, and delete. But it turns out CRUD is a more general concept in databases more generally. In SQL specifically, the command we're going to see and use for reading data, getting data from a database, is technically called select. And if I may, it turns out there's a couple more ways to create and delete data. You can also insert data, which starts with I, so it doesn't really fall into our nice acronym there. You can also drop data, or really drop whole sets of data or tables of data using D for drop as well. So this is to say there's still only 4 fundamental operations, but the verbiage that we use throughout the language might vary from command to command. So what can we actually do with SQL? Well, first we need a database to start playing with. And the data in databases are stored in what we're going to call tables. And tables have rows and columns, which wonderfully is exactly the same mental model that we have in the world of spreadsheets, whether you saw them today in CS50 for the first time or have been using spreadsheets for years, whether it's Google's or Microsoft's or Apple's or anything else. Spreadsheets, of course, also store data in rows and columns. And if you have multiple sets of data inside the same file in the world of spreadsheets, recall that you can create multiple sheets. Now, in the world of relational databases that are used for web applications, mobile applications, business applications more generally, you can have an analog of exactly that same idea. In the world of relational databases, we call sets of data tables that have rows and columns, which is really the analog of sheets in the world of spreadsheets. And the command via which you can create such a table is not quite as simple as going to like the file menu and adding a new sheet or clicking a little plus icon somewhere. This is a programming language, SQL. So if you want to create a table, you're literally going to express code like this by typing it at a command prompt and hitting enter. But where are you going to actually run that? Well, it turns out that in the context of CS50.dev and our own VS Code environment, and really a standard practice in industry as well, would be to use a command line program to access a database. Specifically, we're going to use a database called SQLite, which, as the name implies, is sort of a lightweight version of SQL. That doesn't mean it's a toy language or a toy database. In fact, SQLite databases are used in web applications, mobile applications, and all of the CS50 applications we're going to build here. And what's nice about SQLite is that it stores all of your data in a file on your hard drive or a file in the cloud. It's not a special piece of software per se that needs to be installed and run 24/7, 365 so that you can constantly have access to the data. That is the case with databases like MySQL or Postgres or Oracle or Microsoft Access or SQL Server. There's so many SQL databases out there that are syntactically mostly the same, but certain databases have slightly different dialects, so to speak. They've sort of evolved slightly differently over time. But we'll focus on SQLite, which really is not only light, but has a lot of the core features of any SQL database out there. So in fact, in the real world, if you start to use some other SQL database, you should be quite fine ultimately having this foundation in SQLite itself. Now, how do you use SQLite on, say, a Mac or PC or in VS Code in the cloud, as with CS50.dev? You just need to install the software, which we've done automatically in advance for you, and you can run a command line program called SQLite 3, where the 3 just represents the 3rd version of this here program. So SQLite 3 is going to be a command line program via which we can create a database and also execute commands inside of that there database. The typical syntax for creating a new database with this SQLite 3 command is literally SQLite 3 space and the name of the database that you want to create. So in fact, let me go over to VS Code here and let me go ahead and type SQLite 3. And then let's call this favorites.db. So there's different file extensions in the database world, but .db is pretty common in the world of SQLite for storing your actual database. When I go ahead now and hit enter, it's going to ask me here in cs50.dev, are you sure you want to create this file? And that's just as a quick reminder that it doesn't exist yet, but that's indeed my intent. So Y for yes. And now I'm at a SQLite prompt. So notice it's no longer a $sign, which is my terminal window's default prompt. Now I'm inside of a program that's running continually until I quit out of it, and that prompt is SQLite and then an angled bracket, a greater than sign, just to indicate that I'm not in my terminal per se, my shell, but rather in this here program. Now, I could type some fairly arcane commands and import that whole CSV file into this .db file, but it turns out that SQLite 3 comes with some handy commands to just automatically import a CSV file for you. And what I'm going to do is this. I'm going to type first .mode, and I'm going to put SQLite into CSV mode. Long story short, SQLite can import different types of text files like CSVs, TSVs, tab-separated values, and other formats as well. But I know in advance that I want to import a CSV file, so I'm going to tell SQLite to go into CSV mode. The fact that I started this command with a dot is just specific to SQLite itself. It has nothing to do with SQL per se and the commands we're about to see and use, but anything that starts with a dot at the SQLite command just means you are configuring the SQLite program itself. Now, let's go ahead and import with .import favorites.csv into a table called favorites. So to be clear, I already have a file called favorites.csv. I've just created a new file called favorites.db, and I want to store inside of that DB file, the database, a table called favorites. So this is like having a sheet called favorites inside of a file called favorites.xlsx in the world of Microsoft Excel. I'm just naming everything accordingly. I'm going to go ahead and hit enter. It blinked for a moment, but didn't take very long. And now let me go ahead and just do .quit enter. And .quit gets me back to the $sign prompt as usual. But now, if I type ls, not only will I see favorites.csv, favorites.py, but also now favorites.db, the database that I've just created and into which I've imported all of this data. Well, let me go ahead now and clear my terminal and rerun SQLite 3 on favorites.db, enter. That brings me back into the prompt. And let me now start to poke around. Like, what is it I just did by importing that CSV file into this database? Well, I can see as much by typing .schema. The schema of a database is the design of the database. What table or tables are in there. So if I do .schema enter, I'll see now some fairly arcane syntax, but this was all automatically done for me when I used the .import command. Apparently, what that import command did for me was execute an actual SQL command called create table, if not exists, quote unquote favorites, and then import into that table apparently 3 columns, a timestamp column, a language column, and a problem column. And those are all encased in parentheses here. They are all quoted as you see, and they're separated by commas. Again, these are now these are SQL commas, not in the file itself. But what type of data did I import? Well, the .import command is pretty naive, and if it just sees data, it's just going to assume it's text, text, text. So even if it looks like numbers, it might still assume that it's just text, 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 but we're going to get back to that. In the world of SQL, there's actually going to be proper data types we can do. So long story short, what was the point of this? Well, I didn't want to first start our introduction to SQL by typing out this cryptic-looking command and then manually import all of that data. The .import command just automatically gets me going with a SQLite database containing all of the same data as a CSV. And frankly, you could imagine doing this in the real world. If for work or some future assignment, you've got a CSV file that's part of the assignment or task, you can very quickly import it into your very own SQLite database and instantly start executing the following types of SQL commands on it to answer questions about that data. So let's do exactly that. Let me clear my terminal, but stay inside of SQLite. Let me increase the size of my terminal just because we're going to start to see a lot of textual output. And let me propose that we introduce the first of those CRUD commands via which we can start to read data from a database. Recall that the first command recall that the command for reading data from a database is this, select. So it kind of has the right semantics. When you want to select data from a database, read data from a database, you literally write select. And then you specify one or more columns that you want to select data from, and you specify from what table you want those columns to come from. So what you see here on the screen is sort of the canonical, simplest form of the select statement in SQL. So let's put this to the task. Let me go back to VS Code here, where I have my full screen terminal window, and let's select everything from this favorites table. Let me go ahead and type literally select star, where star in this case is a wildcard representing every column that happens to be in the table. From what table? Well, the favorites table, semicolon. So you do need to, unfortunately, end your SQL thoughts with semicolons, just like in C, but unlike in Python. Now, this is a quick and dirty command, so to speak, in that it's really just going to dump out all of the data onto the screen for me. But when you're opening a database for the very first time, it's kind of a nice, simple way to get started if you just want to wrap your mind around what is it I just opened, kind of like glancing at a file on the screen. So I'm going to go ahead and hit Enter, and very quickly, you see a sort of ASCII art version of that tabular data. So the commas have been interpreted in advance as being delineating different columns. That's why visually we see on the screen these sort of vertical columns or pipes, and that's just SQLite being user-friendly for me. In fact, if I go up to the very top of this output here, you'll see that immediately below my command, I see 3 columns named timestamp, language, problem. So that CSV has been somehow loaded into memory in this 3-column format. Now, suppose I don't really care about timestamp, and for now I don't even care about problems. What more can I do? Well, let me clear my screen and let me select a specific column. So select only the language column from the favorites. And if I now hit semicolon and enter, now I get back essentially a single column table, a subset of that there table. And in fact, that's what I'm doing with each of these commands. I'm sort of creating temporarily in memory a virtual table that just contains the data that I care about. And I'm not doing anything useful with it yet. I'm just dumping it to the screen. But I am essentially selecting these temporary tables with these various commands. Now, this isn't all that much progress, just looking at the very data that I've always had access to. But besides just selecting the data, turns out that SQL, like Python, like C, like Scratch, comes with a whole bunch of functions built in. A lot of these are mathematical or statistical or analytical in nature. And indeed, SQL is very commonly used in the world of data science and analyzing data, consulting and the like, because it lets you very readily, as you'll see, answer questions about data. And for instance, you might want to compute averages, or AVG for short. You might want to count the number of rows in some data sets. You might want to get unique or distinct values from a data set. You might want to force everything to lowercase or uppercase. You might want to get the max value, the min value, and that should evoke recollections of the exercise we just did with trying to find the most popular language in that there data set. So for instance, let me go back to VS Code here, and let's try a couple of these out. In my SQLite prompt, why don't I go ahead and just see how many people submitted this form before I downloaded it into my code space. So I can do, of course, select star from favorites, semicolon, and I could just manually, visually count all of the rows. Like there's got to be a better way when there's hundreds of them, and indeed there is. Per this list of some of SQL's functions, I can use the count function to answer just this. Now, I don't really care what I count. I really just want to count all of the rows. And so the best way to do that is to actually say, canonically, select count star, using the star in parentheses, because count is a function, so I'm passing in arguments. And star, again, is a wildcard that represents all of the columns. And that's fine, because I just want to count the total number of rows ultimately. So from favorites, semicolon, and what I'll now get back is not all of the darn data in the table, but rather a single temporary table that contains just one value of interest. 313 form submissions came in before I closed it and downloaded that file. Now, I made the form, so I know what the candidates for favorite languages are, but there's other things I can do with this data too. For instance, if I want to get the unique values of everyone's favorite language, well, I can use distinct as a keyword here too. This one I actually don't need parentheses for, it turns out, but I'm going to do it here as follows. Select all distinct languages from the favorites table. And this is going to now whittle down that long column of all of the languages that everyone selected into just a list of 3. Because, of course, there's a lot of duplicate Pythons, there's a lot of duplicate Cs, there's a few duplicate Scratches. Distinct just means I only care about the distinct values of language. Now, what if you want to count how many unique languages there are? We can compose these ideas in the same kind of way as in Python and C. I can do select the count of all of the distinct languages from the favorites table. So again, I'm first filtering it down to the distinct languages, then I'm counting those rows from the favorites table, and as you might expect, I get back 3 as my answer. So sort of little tiny bite-sized questions I'm asking, but all very quick and all just with a single line of code. So even though I have the power now of programming, I can still answer questions like my familiar spreadsheet tools long have. But it gets a little more interesting than this. It turns out there's yet other features besides these here functions, and there's some other keywords we can use. And we'll just start to scratch the surface of these to give you representative use cases of these. But it turns out that you can group data, you can look for data that's like a certain value, not exactly equal to. You can limit how much data comes back if you're getting overwhelmed with the number of rows. You can order or sort the data, and you can also use essentially conditionals, filters, otherwise known as predicates, to get back just subsets of data instead. So for instance, let me go back to VS Code once more, and let me play around with a few of these new keywords, and let me propose this. Suppose I care about how many of you really liked C. Well, I could just select all of the data as before and sort of count it up manually, but that seems unnecessary. Let me do this. Let me go ahead and select the number of people who, from favorites, where the language they gave us an answer to their form was equal to quote unquote C. And you'll notice this is the first time I'm using literal quotes. In SQLite, when you want to quote a string value, a textual value, a literal, you use single quotes. And I realize all of these languages have their own conventions, but in SQLite, you would use single quotes around values like C. So what is this asking? This is saying select the count of all of the rows from favorites where the language in that row happens to equal quote unquote C. So this should give me the same number as earlier in code, and indeed, there's that same count, 59. But how did I get it? Notice that I was able to answer this in 1 line of SQL code as opposed to 14 or so lines of Python code. All right, what else might I do? Suppose I want to be a little more specific and I really want to know how many people liked not only C, but Hello World, right? They sort of peaked early in terms of their excitement and really liked Hello World, and then none of the problems since. So how can we express that? Well, let's go ahead and select the count of all of the rows from the favorites table where their favorite language is quote unquote C, and the problem that they love is quote unquote hello, comma, world. That was one of our very first problem sets in C. And so now I'm using this conjunction of checking for the language value and the problem value. Similar to Python, the keyword is indeed and, unlike C where it was ampersand, ampersand, but this is now giving me some Boolean logic. If I go ahead and enter, we'll see that 8 of you, okay, I'm not sure how I feel about that, 8 of you really liked not only C, but Hello World was your favorite problem in question. But we can get back that answer too with just 1 line of code. We don't have to write a whole Python program. We don't have to debug it. We can just express ourselves if in a new way using this here language known as SQL. What, though, have I been doing very carefully stylistically? You'll notice that I keep capitalizing select and count and from and where and then using lowercase as appropriate for everything else. This is a stylistic convention. We've talked about style, of course, in the context of C and Python quite a bit. In general, in SQL, we would encourage you stylistically in CS50, and really in the real world, use uppercase keywords like select and count and from and so forth for anything that's built into SQL itself. And then use the proper capitalization for any tables you yourself have created, for any values that you're searching from. Why? Well, frankly, it just tends to be a little more readable when you can distinguish what is SQL code and what is actual table names and values therein. But this isn't a universal thing. Even different databases and different programmers might have their own conventions. So let me pause here and see, thus far, are there any questions on our use of SQL with any of these keywords here or our prior ones? What is the difference between select and insert? Select is just for getting data or reading data. Insert is going to be for adding new data. We haven't gotten there yet, but we will shortly. So distinct gives you back unique values. Group by we'll get to in a moment. But distinct, we've seen, gives you unique values. Oh, can you chain the commands together? You can separate the commands with semicolons, just as in Linux. But generally, I would say people do them one at a time. We'll see in a moment how you can nest queries, though, as well. A good question. Does it matter if you use single quotes or double quotes? The right way to do it in SQLite is indeed with single quotes. That is the convention. However, SQLite has been around for a while and is very tolerant of different conventions. So it will often work to use different quotes, like double quotes as well. It even supports backticks in some cases. But what we'll try to show you here is sort of the right way to do things in general. And in fact, you'll notice that I'm actually not using quotes around everything. Strictly speaking, it's conventional in SQLite to use double quotes around keywords like favorites and language and problem, because those are symbols that I myself created in my database and in my database table. However, when there is not a corresponding SQL command that is identically named, it's not strictly necessary to quote values. So this is to say I could, to be really proper, do select count star from favorites where language equals quote unquote C and problem equals quote unquote hello world. And again, notice I've used single quotes for my string literals for the values I'm searching for, but I've used double quotes around all of the symbols from my table name and my column names. This is the right way to do this here, but I would say in the real world, it's so much more convenient to omit quotation marks when you don't strictly need them. So that's the habit that I will generally be in as well. All right, if I may, let me propose that besides these commands, we introduce a few other pieces of functionality and then improve on our database as well. So let me propose that suppose that I care about not just the hello world problem, but there was a follow-on problem, recall, in C, where it was hello, it's me, whereby you could actually type in and see your own name printed. So if I want to check for either of those, how can I express that logically? Well, it's very similar to Python and pretty similar to C. Select the count of the rows from the favorites table, where, as before, language equals quote unquote C, but now I want to check for two possible favorite programs. So let me use some parentheses logically, just like you might use in Python or C, where the problem equals quote unquote hello, comma, world, or, and I'm capitalizing it to make clear that it's a SQL keyword, the problem equals, quote unquote, hello, it's me, close quote, close parenthesis, semicolon. But before I hit enter, let me see if anyone can spot the potential bug in this code. I think I've just created a problem for myself by advocating for one style or another. The problem is that we seem to have, for my hello, it's me problem, there's actually 3 single quotes involved, one of which I'm using as an apostrophe for it. And this is going to be problematic because just like in Python, just like in C, the language, the computer is not going to really understand where the string begins and ends if there's this ambiguity. Now in C, and also to some extent in Python, the way we generally solved confusion like this is we would escape the value using backslash. In SQL, it turns out that you don't just put a backslash in front of the apostrophe in this case to avoid that problem. Weirdly and admittedly confusingly, the convention is to actually use 2 apostrophes. So this does not create one string on the left and one string on the right. Having 2 single quotes in a row means you only want one of them logically to be there. So this assuages that concern there. So if I now go to the end of my command and hit enter, this time it worked because now it turns out that 8 of you liked hello world. I'm inferring that none of you liked hello it's me any better because the count is still 8. But at least now if we get more data over time and I update the CSV and in turn my database, I would be checking for both the language of C and either the problem hello world or hello, it's me. But really the goal here has been to experiment with some of the slightly different syntax that we need to express some of these here problems. But you know what? What if I wanted to express this even more succinctly and I really just care about any of the hello problems themselves, be it hello world or hello, it's me? Let me propose to use one other keyword that's on our new list here, namely like, where you want to search for not necessarily something that's exactly the same, but like a value, so to speak. So let me go back to VS Code here, and let me do, as before, select count star from favorites where language equals quote unquote C, and here's the new part, the problem is not equal to, but rather like the following value, hello, comma, something. Now, how do I express something? Well, here there's another piece of syntax that we need to introduce. We've seen the asterisk or the star being used with count and in other contexts for selecting any number of selecting all of the columns available. But when you use the like keyword, if you want a wildcard, you actually use, a little weirdly, a percent sign instead. So if I now do hello, comma, space percent, in this context of using the like keyword, SQL will now search for all of the problems that start with HELLO, comma, space, and then 0 or more other characters after that. And because I'm being a little clever here, I know that both of the problems I care about start with hello, comma, something. This should be equivalent to the previous command, but I don't need to have a special list of all of the values I'm looking for. This will get everything that starts with hello, comma, space. And indeed, I still get back my 8 rows as before. All right, how now might we use some of these other commands too? Well, it turns out that with group by, we can actually group similar values together. So how might this be useful? Well, consider this sample table here. It doesn't have nearly as many rows, but I propose that suppose I collected a small number of form submissions that just had maybe these 6 submissions. One person liked C, 3 people liked Python, and 2 people liked SQL. Well, we haven't yet seen syntax via which we could replicate that earlier Python program, whereby I really want to be able to get a quick analysis of how many people like C, how many people like Python, how many people like SQL. Obviously, I can just skim the list visually here because it's short, but if there's hundreds of submissions, let alone thousands or millions, it would be nice to be able to answer that question without having to write a dozen or more lines of Python code for a relatively simple and pretty common question. So how might I do this? Well, let me go back to VS Code and let me introduce that group by syntax. Let me go ahead and select the language column and the count for that language from the favorites table. But how do I want to do this counting? Well, let's go ahead and group those rows by the language value. So the only thing that's new here now is group by language. And what this is going to do for me is the following. If I go back to this here visualization, notice that the possible values are C, Python, and SQL, but there's several of Python and SQL. So how might I go about analyzing this? Well, really notice there's one value for C, there's these 3 values for Python, and there's these 2 values for SQL. Wouldn't it be nice in kind of your mind's eye, you could take this table and kind of squish it vertically, grouping all of these similar values together. Combine all of the C values, all of the Python values, and all of the SQL values, as we've now left scratch behind. Well, how can I do that? What I really want is to get back an answer like this. I do want the count of something, but I want to group that counting by the specific value for language. I don't want to count up all of the rows as I keep doing. I want to group my counts by the value in the language column. So how might I express this with exactly this code? If I want to get back a 2-column temporary table, language in the left column, the count thereof in the right column, but I want to squish this together in my mind's eye and combine all of the similar languages together and then count those, I do, at the end of this query, group by language. And if I hit enter now, I get back that same analysis as earlier that we implemented in Python, but using a single line now of SQL code. How might I improve on this further? Well, notice here that currently what I've just selected is indeed the counts, really in the order seen here, C and then Python, then Scratch, which seems to be alphabetized in this particular case. But it would be nice, frankly, if I could actually sort this by count. Not so much because I have a lot of data here, but if you had lots of different values in a much taller table, it might not be as obvious which is the biggest, so it would be nice to just do the sorting ourselves. So how might I do this? Well, let me go ahead and do a similar query, and just as in Linux, in your terminal window, in SQLite, you can actually hit the up arrow and go back through your recent commands. So I'll start to do that now to save myself some identical keystrokes. Let me go ahead and instead of just ending my thought with a semicolon, let me actually say order by the count of those rows. semicolon. If I hit enter now, you'll see the exact same data, but it is indeed sorted by the count column. Unfortunately, just like with my earlier Python program, I accidentally sorted it backwards. It's from smallest to largest by default. In fact, what's implicitly happening here is that I'm ordering it by count in ascending order, ASC for short, whereby ASC indicates ascending order, so from smallest to largest. But if what I want to do is actually do this in descending order, I can actually do DESC for descending, hit enter here, and now I actually do get a sorting version of this from largest to smallest instead. Now, this temporary table I have here is a little weird because one column's called language, the other column's called count star. Turns out there's another trick we can use in the context of SQL if we actually want to rename these columns that we're getting back from our queries. And we can alias these things in the following way. Let me go ahead and now do this. Select language, comma, count star. But if I want to give this count star column an alias, a nickname, n is our go-to value for numbers, for instance, in programming. So let me rename this from count star to just n for number. And then let's do this as before from favorites. Let's group by language and let's order by, and now this might make a little more sense. Let's order by n in descending order, semicolon. And now I get really back the same result, but I indeed see language as the column name at left, n for the column name at right, and that's just a little more explicable. And in fact, this will be useful in code if you want to give aliases to the headers you're getting back so that in Python or some other language, you don't have to keep typing count star, count star. You can use nicknames or these synonyms instead. And just to show you one other query, one other keyword that flashed before our eyes earlier, there's also this limit keyword, which isn't super useful with this relatively small data set. But if you've got hundreds, thousands, millions of rows, you might want to limit the results to be just the top 10 or the top 1 because you might not care about all of the other data. Well, I can do that here in SQLite as well. Let me go ahead and clear my screen. Let me go hit up so as to open up the previous command. And let me add to the end of this statement limit 1 if what I really care about this whole time is what is everyone's most popular language. Enter. Now I get back just that answer. And there we have it. The most popular language with a total of 243 favorites is indeed Python. To be fair, our queries have gotten a little longer, but by just using these building blocks and those we've seen prior, we can express in really single lines of code what previously took us half a dozen or a dozen or more lines of code in, say, Python. Let me pause here now and see if there are any questions. Yes, a really good question. Unfortunately, yes. And I think as you're getting started with SQL for the very first time, like that's going to be one of the mistakes you and I commonly make by just getting things out of order. So I've been very careful with my cheat sheet to do things in the correct order, but even I forget sometimes and have to look it up or ask CS50's duck or the like. A really good question. Short answer, no, because the way the Google form was designed was to only store values in the CSV if those options were selected. If no one liked a certain problem or even a certain language, we would have no evidence thereof. We would have to go back to the original form and maybe create a new table that contains all of the original authoritative answers, but that have nothing to do with what people selected. So indeed, as you'll see in Python, you might want to even validate data. There's probably some hackish ways where a malicious user could submit data into the form that wasn't actually on the form unless Google too is doing validation. So that's a compelling use case for exactly that same solution. A really good question. So I'm following the same paradigm in mathematics, whereby if you are doing like multiplication followed by addition, and you want the addition to happen first between two values, you have to parenthesize that in math. Similarly here, what I cared about logically was that the language was C, and the problem was hello this or hello that. And so I expressed with parentheses the fact that I only cared about one of those latter being true, but I definitely wanted language to be true. And so parenthesizing in that way ensures that the operators are handled in the priority I intend. So in the case of the form I created, there were only specific values allowed. Hello, comma, world, and hello, comma, it's me. Names were not supported in the list of options I gave to the user. So I don't think this is a concern in my analysis of that data because I know from the get-go what those values are. Even that said, if I were to use that like expression, hello, comma, space, %, if there were a third, if there was a fourth, if there were a fifth option in that form that started with hello, comma, something, we would also take those into account. So that might be a little too overly generous and indeed not the best design. Well, before we move away from this favorites data set, allow me to propose that we look at just a few other features before graduating to a real world, much larger data set as well. So in addition to being able to create a table, which we automated earlier, and in addition to selecting data, as we just did hands-on, you can indeed insert data into a table as well. This wasn't relevant in the case of our Google form because you all used a Google form to insert that data. But before long, I bet we're going to be writing software, wink, wink, whereby we're going to programmatically, in code, need to insert more and more and more data based on what someone maybe types into a form of our own. The canonical syntax for insertion is indeed this, whereby I can insert into the table name, and then in parentheses, I specify one or more columns for which I have values. Then I literally say values, and then in another set of parentheses, I specify one or more values that I want to insert respectively into those columns from left to right. So the syntax here is a bit more verbose, but let's go ahead and try this out. Let me go ahead in my VS Code and go and type insert into the favorites table. How about just the language column and the problem column? I don't really care about the timestamp. I don't want to figure out what time it is now and write it in the right format. So I'm only going to insert two values, not three, specifically language and problem. The values I want to insert are going to be quote unquote SQL, because I'm a big fan of SQL all of a sudden. And the value for problem is going to be 50vil, a problem that awaits you as well. Then I'll hit semicolon enter, and nothing seems to happen. But if I quickly do select star from favorites, which again is a nice quick and dirty command for just seeing all of the data in a table, look at the bottom of the table, I actually do see a new value, namely SQL and 50vil. Now, curiously, there is a value for timestamp, but it's a special value, and we've seen this value by name before in C, that of null. So in the world of C, recall that NULL, with two L's, represented a zero pointer, an invalid pointer, or just an initialized value that has no valid address. In SQL, this has nothing to do with pointers per se, but we still use null, in all caps, NULL, to represent explicitly the absence of a value. And this is actually a really nice feature of SQL. Imagine the world of Google Sheets, Apple Numbers, Microsoft Excel. Humans make a mess of their data all the time. For instance, if you don't have a value in a cell, one of those rectangular boxes in a spreadsheet, does that mean it's deliberately blank? Does it mean you don't know the value? Does it mean you're missing it and you're going to come back later? So what do we humans do? Well, in English, we might have a convention like writing N/A for not available, maybe lowercase, maybe uppercase, but that's a complete hack, because what if you want the cell to actually contain, for whatever reason, N/A? It's ambiguous. So maybe you color it in a different color, like maybe black it out in the spreadsheet just to indicate, no, there's nothing here. But a color is not an explicit value for a cell. So in the world of spreadsheets, it's actually harder to express the deliberate absence of data than it is here in SQL. So when you have a null value, that means I or someone has made a conscious choice to not put a value there. It is not the same as quote unquote nothing, the so-called empty string. It's not a blank value. It is the conscious, deliberate absence of a value instead. So that there is a plus. Now, suppose I want to actually get rid of something now. Turns out there's other features, indeed, of SQL we should explore, not just the insertion of data, but the deletion of data as well. Now, this one is pretty simple. Delete from table where some condition is true. But anytime, as in the real world, you can make really bad decisions and make really big mistakes by deleting data that you did not intend. So for instance, let me go back to VS Code here, and let me propose that I want to get rid of this SQL value because it wasn't in the original form. I'm really just playing around here. I can start my query with delete from favorites, And please, 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 especially if working as an intern or a full-time engineer in industry, do not ever end this thought with semicolon unless you know what you're doing. Because if I were to hit enter on my keyboard now, this is how you would delete everything from the favorites table. This has happened before. There are news articles about employees doing really bad things because they deleted data they shouldn't have. So let me just delete my semicolon and finish this thought, as per this slide where I'm saying you should really use a where condition. We used where before for select, where we only wanted to get a subset of data. Presumably when deleting stuff, I probably only want to delete a subset of my data, maybe one row or a few, hopefully not ever all. So let me specifically delete from favorites where the timestamp column, capital T, because that's how Google does it, is null. And this too is a little weird. Instead of saying equals null, the right way in SQL is to say is null, or conversely is not null, to express that you literally are checking for that absence of a value. So this I'm more okay with because I know that all but one of my rows has timestamps. So if I hit enter now, nothing seems to happen. But if I do select star from favorites, semicolon, enter, notice the bottom of my output no longer has that SQL or 50vil value. Now, I will say there's other things too we can do with our data set, not just insert, not just delete, but also update existing values. And this syntax is a little wordier, but it does what it says. If you want to update a table and set one column equal to some value where some condition is true, you can express that with code like this. You can actually set multiple values at once by separating column equals value, comma, column equals value, comma, column equals value, and so forth. But for now, I'm going to go ahead and set two things to known values. Suppose that, I'm really getting excited about SQL. I really hear good things about this 50vil problem. Let's kind of change this data and decree that everyone's favorite language as of today or this coming week is going to be SQL, and their favorite problem is going to be 50vil. So I can do this, albeit destructively. Update favorites, set everyone's language equal to SQL, and everyone's problem equal to, quote unquote, 50vil, semicolon. I haven't executed this yet, but what this means is that it's going to iterate over the table, top to bottom, and because there is no where clause, I am going to change every cell to equal SQL and 50vil, respectively, in the language and problem column. So this too, probably not something you should do in the real world, certainly not when working for a real world company with a real world database, unless you want to blow away all of your data and replace it with SQL and 50vil, but let's do that. Enter. Nothing seems to have gone wrong. Let me do another select star from favorites, and I really hope no one has questions about the previous version of the data set, because now everyone loves SQL and 50vil. And unlike most computer software, I cannot just hit Control or Command Z to undo. What you have to do now is exit out of SQLite, hope you made a backup of your database earlier, which I didn't, and then restore somehow from backup. So beware the power of these commands that you now have at your disposal. All right, so that was a lot, and unfortunately we're out of data now, the hundreds of rows that we've had, but that was never a lot of data to begin with. So in fact, let's go ahead here and take a few minutes break, and when we come back, we're going to graduate from hundreds of rows to millions of rows of data. Indeed, we're going to introduce you to a real-world data set known as IMDb, the Internet Movie Database, which has lots and lots of information about movie stars, movies, and TV shows, and so much more, and we're going to use some of that publicly available data to explore SQL all the more, but also the design of our databases. But let's come back in 10 minutes, and we'll pick up there with millions of rows suddenly. All right, we are back, and we now dive into the Internet Movie Database, or IMDb for short, which again has a lot of real-world movie stars, TV shows, movies, writers, directors, and so much more. And all of that data, it turns out, is downloadable in TSV format, tab separated values. And so among the things we've done before class today is we actually wrote a program of our own. Turns out it was in Python, but it could have been in any language, to automate the process of importing those TSV files into our very own movies and TV shows databases. For today's, we're going to focus on TV shows in the world, with which many of you are